In this video, I will go through FS1 Chapter 1 Section 1.2, which is variance of discrete random variable. Okay, so just little explanation first. If you take a set of observations for a discrete random variable, you can find the variance of those observations. Okay, as the number of observations increases, these values will get closer and closer to the variance. Okay, what we mean by variance, how the data varies basically, is a variance. So I will give an example here. Okay, and hopefully it will become more and more clear. So first of all, let's write down the two important formulas for the variance. So if you remember from the last lesson, the expected value of the discrete or any variable we were showing with E of x. Similarly, for the variance, we show with VAR of x. Okay, variance of x is equal to E of x minus E of x, close bracket, all square. Okay, close the square bracket. That's one formula. Another formula which are equivalent, you should get the same answer using both formulas. E of x squared minus E of x all squared. Okay, so in first case we are squaring x, in next case we are squaring E of x. I could put one more bracket just to make it more clear. Okay, so here is the formulas. Let's go through an example. So hopefully it will be a lot more clear when we go through the example. A fair six-sided dice is rolled. The number on the uppermost face is modeled by the random variable x. Find variance of x. Okay. To find the variance of x, let's first draw the table. Okay. So we've got to draw 4 rows for this table. Okay. X, then 5 rows maybe. Probability of x equals to x, then x squared. Okay. We will need x minus E of x squared, x minus E of x all squared. Okay. Then we might need probability of x squared equal to x squared. Just in case I write it down. So 1, 2, 3, 4, 5, and 6. These are the possible outcomes. Okay. Right. Probability of getting 1. Since it is fair dice, so it would be 1 over 6 for all of them. Okay. So x squared is 1, 4, 9, 16, 25, and 36. Probability of x squared equal to x squared is 1 over 6, 1 over 6, and so on. x minus e of x squared. So first we need to work out e of x. E of x is equal to sum of x times probability of x equal to x. In previous video we worked it out, which was 3.5 for fair six-sided dice. Okay, so therefore we don't need to really work this out now. X minus e of x squared. So 1 minus, for example, for the first one, 1 minus 3.5 squared. Okay, so let's calculate this. Okay, minus 3.5 whole squared. Okay, so 1 minus e of x, which is 3.5 whole squared, which is minus 2.5 squared, and 2.5 squared is equal to 6.25. Okay, similarly next one is 2.25, then next one is 0.25, next one is 0.25, 2.25 and 6.25. Okay, let's write down the formula for the variance. Okay, variance of x is equal to sum of x minus e of x all squared times by probability of random variable x equals to x. Okay, 6.25 times by probability of x equals to x is 1 over 6. Okay, add 2.25 times by 1 over 6, add 0.25 times by 1 over 6, add another 0.25 times 1 over 6, add 2.25 times by 1 over 6, and finally 6.25 times by 1 over 6, which we get 35 over 12. Okay, so let's call this one method 1. Okay, and let's use the second formula which I introduced in the beginning. So first, for the second formula, I mean this one, so we're gonna to use e of x squared. So what is e of x squared? E of x squared is equal to sum of x squared times by probability of x squared equals to x squared. Okay, so or probability of x equals to x. In this case, x squared equal to x is the same as x equal to x. Okay, so probability is 1 over 6 times by x squared, which is 1 plus 4 plus 9 plus 16, 25 and 36, which is equal to 91 over 6. Okay, so therefore, let's write down the formula again. Variance of x is equals to e of x squared minus e of x whole squared. So 91 over 6 minus, we know e of x is 3.5, 3.5 squared. Using our calculator, we should get 35 over 12, which is the same as previous one. So after watching this video, you should be able to do exercise 1b from FS1 at Excel, which is page number 6 and 7. Okay, so in next video, I will go through some of the examples, some of the questions from exercise 1b.